everyone. Nice seeing your faces. Today, I'm Dino. I'm going to talk about building a MIDI sequencer in Elixir. I know I'm all standing between you and a coffee break, so I'll be brief and I'll try to be quick. Heads up, I apologize in advance if there's any musicians in the room. I'm no musician, so I'll mess it up. I also apologize if there's any MIDI experts, because I'm also not one. With that out of the way, what is MIDI? MIDI stands for Musical Instrument Digital Interface, and it's a fancy way to say it's a communication protocol that allows digital devices to send and control messages for musical instruments. So think, for example, you have a keyboard and you have a synthesizer, and you play your keyboard, it sends messages to the synthesizer that then plays the sound for you. And there's three important concepts we need to understand when talking about MIDI messages, which is notes, velocity, and channels. So notes are basically, if you look at the keyboard of a piano, you'll see this repeating pattern of 12 notes. You can call this repeating pattern like different octaves, and then with MIDI, you can represent the notes basically with integers, and we usually always start at C. So C, you can say it's 60, then C sharp 61, D 62, and whenever you get to the end of this and you go to the next octave, you just add 12. So 72 would also be C. And then velocity is basically just specifying how fast or hard you press a key on a keyboard. Can be any value between 0 and 127. Not all synthesizers may do something with this information, but think when you're playing a piano, if you play like softer, the sound comes a little bit lower. If you play harder, the sound comes a little bit higher, I would say. And then lastly, channels are basically a way to specify to which instrument the message is specified to be delivered. And this is usually configured, so you can send on the message specify with the channel, and then on the recipient you can specify in which channel you're listening to. So for example, here you can see that both instrument A and B, one of them is expecting messages on channel 1, the other is expecting messages on channel 4, and instrument C will process any message regardless of the channel it is being sent on. So moving on to the message format. It always starts with a status byte, where the most significant bit is set to 1, and optionally you can send data bytes, where the most significant bit is set to 0. And so, for example, let's look at the note on message. You can see that this message starts with 1001 for the most significant bits, and then the 4 least significant bits are where you specify the channel. In this case, it's all set to 0, so it's going to be on channel 1. Then you have 2 data bytes. So the first data byte is just a note, and I'm just going to refer to the decimal values because it's easier. 60, it's the C note we saw on the previous slides, and then the second data byte would be the velocity. So in this case, 120. And then for the note off, it's basically pretty much the same. You can see that only the 4 most significant bits of the status byte change. So now it's 100. But again, channel 1, data byte, it's the same note, so we're basically saying turn off this note that I previously turned on. And velocity, I don't know if they do anything with this value. I just set it to 0, and it seems to be working, so let's not worry about that. And thankfully, I didn't have to do almost any work, because someone already wrote a library to interact with MIDI using Elixir, which is also, I think, a wrapper over MIDI-R, which is a Rust library. Thank you. And so how you use MIDI-X? Sorry, I got ahead of myself. You can use the ports function to basically specify that you want to list all of the MIDI ports that are in your system. This can be both output or input ports. Output just means where you send the messages to. Input is where you're getting the messages from, right? So in this example, I'm just calling the ports function. I'm passing the output atom, getting the first port and then opening a connection to it. So I can then send messages to it with the send_message function. Now the message, you can just like use binary, and you notice that I'm using decimal just because I was referring to that on the previous slides. So if you're paying attention, 144 is just a note on channel 1, 60 is just that C note that we saw on the previous slides, and 120 is just the velocity. So then I can just call send_message, and this would turn on that note for the recipient. And note off, same thing, just the message is different. You send 128, is just note off on channel 1. With that note, 60, and then you can just send this message. So how do you go from here into actually building a sequencer? Now, a sequencer is nothing more than something that plays a sequence of notes with a specific interval between all of these notes. And if we look at it from this way, we can see like we have this sequence. I'm using atoms here, so I'm saying like C4 is the C note on the 4th octave, E4 is the E note on the 4th octave, so on and so forth. You get the gist of it, I think. And so basically what a sequencer would do is like it sends the note on MIDI message to C4, and it waits for a specific amount of time, and it continues to the next step. So when we get to step 2, what we do is we send the note off to the C note that we played on the previous step. We send the note on to the one on this step, second step, and we wait again. And then we go to the next step, third step, we do the same thing. Turn off the E note, send the note on, MIDI message for the F4, and then wait again. Do this all the way to the end of the sequence, rinse and repeat, basically. And how do you determine this interval that each note should have to wait before playing or being turned off? It depends on basically on the tempo of the song, which is usually expressed in BPM, which is beats per minute. In our case, we're going to simplify. Sorry to everyone watching at home, but basically 120 BPMs, you can consider it's 120 quarter notes per minute. Quarter note is basically just how fast a note is played. And then we know that 1 minute has 60,000 milliseconds, or it usually has. And so if you divide that number by 120 quarter notes, you'll get to the result that each quarter note should last for 500 milliseconds, or half a second. Instead, if you are playing eighth notes, which is half the duration of a quarter note, you can just divide that result by 2 and you get 250 milliseconds. And you do the same thing for like a 16th note, you'd halve the duration of the 8th note, basically. Hope that's clear. And so a quick diagram of what the project used to look like, or how you can get this to work, is you have like the sequencer is just a gen server, which is calling the process.sendAfter function, which basically it's telling, okay, I'll send a message to myself after this amount of time, let's say it's 500 milliseconds. And then when the timer runs out, you get that play message on the gen server, which then is handled with handle info, and you use MIDIX send_message to basically turn off the node and turn on the next node. And then you schedule that again using process.sendAfter, basically. And this was all fine and dandy up to the point of like, it works, but first it isn't super precise because sometimes you put 500 milliseconds and then it's actually 502 or 498. You can never like be super precise with it. And also you'd be limited to the fact that you couldn't actually sync with external devices because they're running on like different clocks and different things. So I had to look for another way. So that's where MIDI system real-time messages come to the rescue. And these are MIDI messages like the first ones we saw, but they're different. They're not about what notes are being played. They're more about if the song is playing and how fast it is playing, right? So you can send like a MIDI start message. Don't worry about the binary, it's just there so you can see it. You can send a MIDI start message, and this just basically tells all the MIDI devices that are listening to this message to start playing. And if the song is already playing and then they receive this message, they will reset the song position to the beginning. And then you have MIDI stop, which it's in the name, it stops every device that is playing. And then you have MIDI continue, which basically just tells the devices continue playing from where you stopped, basically. And then the most useful for us is MIDI clock. So MIDI clock is basically a message that is sent at consistent regular intervals, and that tells other devices that are listening to this message how fast the song is playing and when they should. They use that information to know when to play a note, when to turn off notes, basically. And this is sent at a resolution, usually, of 24 pulses per quarter. And this means that for every quarter note, you should get 24 MIDI clock messages. So if you look at the diagram on the top, it's basically you get the first MIDI clock message, you play the quarter note, 23 MIDI clock messages will follow, and then when you get the next one, it's going to be the first MIDI clock message for the quarter note. So you play the next quarter note and you turn off the other quarter note that was playing, basically. And for the same thing we talked above, if you're playing eighth notes, you'll still be getting the same resolution. So you still get 24 MIDI clock messages per quarter note. But now you know that you should play a new note every 12 MIDI clock messages. And you can do the math for 16 or 32 note length messages, sorry. And basically, how do you also calculate the interval between each of these MIDI clock messages in case you need to send it? Same thing, 120 BPM, 120 quarter notes in 60 seconds. You grab those 60,000 milliseconds, you divide by 120 times the number of MIDI clock messages you get per quarter note, and you get to the result that you should get a MIDI clock message every 20.833 milliseconds. Again, if the song is going faster, so if the BPM is higher, this interval would be much shorter. And if the BPM is lower, this interval would be way higher, right? And so what the project is now doing is we have a MIDI device, which in our case will be the little device I'm holding here, and I'll show it to you in a minute. Don't want to ruin anything. And it's connected to the gen server, which is basically just receiving all of these MIDI messages from the device, be it MIDI start, MIDI stop, MIDI continue, MIDI clock, and then just forwarding these messages to all of the sequencers that are playing with Elixir. And so with MIDI-X, you can also do this by simply picking an input port. In this case, I'm just picking the first input port, and then I'm subscribing to it. And what this does is that the process that called the subscribe function is going to start receiving messages from the device that should be processed with handle info. And again, you can do whatever you want with the message. You can forward it. You can do something on your own. Whatever. It doesn't really matter. But let's see it in action. Hopefully, nothing's messed up. So I'm going to try and explain. I have this little thing that is here. And what this does is, it also has sequencers here, but we're not going to use it. Actually, we are. So 3 of the tracks are going to be playing here, and then 3 other tracks we are going to be playing, right? Because it has multiple tracks, and each track is expecting MIDI on a different channel. So channel 1 will be the kick drum, channel 2 the snare, and channel 3 hi-hat, right? And so if everything goes according to plan, okay, we have 3 different sequencers. It's basically kick, snare, and hi-hat. And when I press the play button on the device, and you'll see I'm not touching my computer, don't worry, it's going to start playing both sound. Let me kind of turn this off. And the sequencer should start moving, right? And so what is happening is they all got the MIDI start message. They started playing. If I press stop, you'll see they stop wherever they are. If I press start again, they'll continue from they are. But I thought it would be funnier if I actually didn't do the drums and you all did the drums. So I have some QR codes for you folks to use. I think there's a limit of like 10 people or something. I don't know. And Grok would know. But I can see some requests coming in. If you start adding things, was that enough time, or is it not working? Because I'm not seeing any notes here. It's not. It's the Wi-Fi's not good. I knew this would happen. So yeah, I'll do it myself, I guess. Can I see? I can see what I'm doing. Yeah. Okay. I'll just wing it. You can see. Oh, someone got in. But yeah, like you can basically just play around with what you have here. And so at the same time, since this is controlling the speed at which the song is playing, if I change the speed here, it should reflect on the sequencers and they should all stay in sync, right? Which is what I'm gonna do right now. So yeah, I guess that's the whole demo for today. But yeah, I'm sorry it didn't work out better, but get the gist of it. I'm gonna stop it now. And let me go back to the slides. So yeah, how this basically works, that was just basically a live view where when mount is called, I'm just basically searching for the first output port, starting the sequencer, in this case multiple of them, right? I'm starting 3 of them. And then whenever one of those buttons is pressed, we basically just trigger a update node event with a specific step in which that node was, as well as what the node was pressed. And then on the gen server side for the live view, we basically just handle that event. We update the sequence on our end, and we just say to the sequencer, hey, this is the new sequence you should be playing. And then you had the other part which didn't actually work according to plan, but you were able to use it, don't worry. And basically what this does, if you looked at the URL, if it was even working, is at the end you see the PID of the sequencer. So basically when it is mounting, it's getting that PID and calling the sequencer to try and get its state so that it can display the correct information. And then it's subscribing to a specific topic for that sequencer. So each sequencer has its own specific topic that you can subscribe to and then get messages from there. And then whenever the state of the sequencer is updated, it just broadcasts that new information to all the subscribers so that you can actually update the interface to actually match with the new state of the sequencer, so that any subscriber then would be called on the handle info and update the live view socket accordingly. Quick diagram, this is mostly what we would look like. There's a live sequencer, there's the client that you folks were supposed to be using. It didn't work out. You just update the state on the sequencer, and then sequencer just uses the broadcast from function from Phoenix pub sub to basically broadcast this information to all the clients, which then is handled with handle info. And that's pretty much it.
Yeah, you sequenced this perfectly. So we have some time for questions as well. So, are there any questions from this room? Yes, all the way in the back, of course.
Hey, thank you for your presentation. So, as I understood, the output of these signals was the MIDI device which is playing music.
So the Elixir was basically just sending messages here, and this was actually triggering the notes that you were hearing. So the whole thing was this device here is sending MIDI clock to the computer or to the gen server running on Elixir, and then the sequencers are using that MIDI clock to output the MIDI note on messages to the device itself, so it all plays in sync. But yeah, everything is being routed here.
Yeah, thank you.
All right, somebody else also raised their hands. Yeah.
Hi, I had my answers partially, but would it be possible also to connect other MIDI devices as outputs that we can collaboratively send signals? And you mentioned about MIDI clocks. In that case, would that synchronize, or again, latency would be a killer?
Yeah, I'm gonna pull the one like it worked on my machine because I tried it at home and it worked. Okay, so it's definitely possible to. I tried it at home. I just didn't want to bring a bunch of things with me, but basically you can use this or any other device to just be the one sending MIDI clock, and then you can output that MIDI clock message itself to other devices. So even to this one, you could just set it so it expects MIDI clock in, and then you could have them all playing at the same time, with Elixir being the one that is propagating or broadcasting those messages to multiple sequencers or multiple synthesizers. Yes, you could have them all play together with Elixir. Yeah.
Okay, one more question.
Have you used Sonic Pi, which has an Erlang-based sequencer and can take? That's one part of the question. I did use Sonic Pi to try and make collaborative stuff using OSC, and it was like a drop-down Tetris to try and get them to play a sound, but everyone was so drunk it was a shambles. So, if you've got any clues on how to do collaborative music with drunk people would also be handy.
Yeah, I think I tried Sonic Pi like 3 or 4 times before. I like it, to be honest. I'd be down to like look into the code base, but I think it's like maybe too complicated for me. I'm not that smart. I just like I had this stuff laying around that house at my house, and I was like, maybe there's a way to use it. And I forgot what the second part of the question was. Sorry. Sorry. But yeah, no, I haven't looked that much into Sonic Pi, to be honest. I did try looking into OSC once, but I couldn't figure out how to actually call it from like Elixir. So yeah, I just gave up and went the easy way, basically. If that makes sense.